Hey everybody, Miss Teacher here. We're taking a look at lesson 7.3, which is on write algebraic expressions. Our essential question is, how do you write an algebraic expression to represent a situation? So let's take a look at what do we mean by algebraic expression and what is it? An algebraic expression is a mathematical phrase that includes at least one variable. A variable is a letter or symbol that stands for one or more numbers. So these are all algebraic expressions. Why? Because we have a variable here, we have a variable here with the y, we have a variable here with the a, and those are holding the place for a number. Now, some things you need to know. There are several ways to show multiplication with a variable. Each expression below represents 3 times y. So we can show it with a 3 and then the multiplication symbol with the y, which, by the way, once we start getting into algebra, this is not the preferred way to write it. And the reason why is because this can often be misinterpreted as another variable, x, which is commonly used. So we try to get away from that whenever we're working variables into anything. This is kind of the preferred way to do it, just to write the 3 next to the y. That would imply 3 being multiplied with y. Some people like to use the parentheses, that's perfectly acceptable. And some people like to use the dot. However, I'm not a big fan of the dot just because it can be misinterpreted as a decimal. All right, moving along. So when we think about all the operations that there are, right, the main operations, there's subtraction, there's multiplication, there's addition, there's division. So when you're looking at words, how do you know which one of these operations it is? Well, let's try to brainstorm this idea. So let's start with addition. What are some of the words that you'll see that might suggest that we're talking about an addition expression? Words like added, or combined, or total, sum of, those all would imply addition. How about subtraction? Can we think of any there? How about decreased by, or difference, minus, less than? Those all would suggest subtraction. Can you think of some for multiplication? How about words like multiply, product, times? Now, one that I want to throw out there also, that idea of the word double. If you ever see the word double, that usually means that you're multiplying something by 2. And if you see the word triple, that usually means you're multiplying it by 3. So words to know. Division. You might see divided by, quotient, shared equally. Another one that you might see is half. Now, if you see half, you can either think of that as divide by 2, or you can think of that as multiply by 1/2 or 1/2. So be careful with the ones that can be really in 2 different categories. All right, so let's take a look at some other things that you'll need to know. This really fits more with the Go Math lesson for 7.4, but I thought it'd be good to slip this in. So anytime you see an operation like a add or subtract and you see stuff around it, you have to be able to define what those things are. So first of all, let's talk about the word terms. The terms of an expression are the parts of the expression that are separated by an addition or subtraction sign. So if we think about this is a term, and this is a term, because here's the addition sign, right? Term, term. All right. A coefficient is a number that is multiplied by a variable. So see, here's the variable, and we know that 4 is being multiplied by it. Why? Because we just talked about the fact that 4 next to a number like that means it's multiplied. So this is a coefficient. Coefficient is the 4. The term is the 4k and the 5. All right, so we have to be careful with that because that's easily mixed up. All right, so if they wanted you to write an algebraic expression for the cost, let's read this and try to dissect it a little bit. It says, an artist charges $5 for each person in a cartoon drawing. Write an algebraic expression for the cost in dollars for the drawing that includes P people. So when they give you the variable, that means you have to use that. And you also have to ask yourself, what's really happening here? So I like to even think of a hypothetical number of people and ask myself, well, what would I do if, let's say I had 3 people? What would I do with the 5 and the 3? And then that often helps you to realize, oh, I'm supposed to multiply that. So when we write the expression, we think to ourselves, We know that it's $5 for each person. We know we're multiplying, and then we're using the variable p for people. So an easy way to write that is just 5 times p, or 5p. That's the simplest way, the more preferred way to write that expression. All right, let's move along to a couple other examples. Let's look at this one. The table shows the number of points that items on a quiz are worth. Write an algebraic expression for the quiz score of a student who gets M multiple choice items and S short answer items correct. So the first chunk of this is going to be 2 times M, and then we would be adding, right, because we have that idea of plus, we're going to be adding the points for the short answer items. So that's 5, right? 5 times S, because why? The points for the short answer are 5. The points for the multiple choice are 2. Now, when we put it all together, we would say this is the same thing as 2 being multiplied by M. And if we kind of clean that up a little bit into its most concise way of expressing it, we would write it as 2M plus the 5S. All right, let's look at another example. Write an algebraic expression for the word expression. 30 more than the product of 4 and X. So we always want to go back and think about some of these words that we're seeing. We're seeing the word more. We're seeing the word product. You have to think about what did we say that those words usually suggest? So we want to think, start with the product of 4 and X, then find 30 more than the product. So if we think about the product of 4 and X, we're really multiplying the 4 and the X together. So the preferred way to write that, by the way, is the 4X. And then we think about 30 more than the product. That means we're adding 30 to that. Now, keep in mind that there is the idea of commutative property. If we had switched the order of these terms, in other words, we put the 4X first and then the 30, that would be perfectly acceptable. Now, speaking of terms, let's make sure we know what the coefficient would be in this case. So 4 is the coefficient, 30 is a term, and 4X is a term, just to reiterate some of the vocabulary that we talked about just a few minutes ago. All right, so if we look at B, 4 times the sum of X and 30. Think, start with the sum of X and 30, then find 4 times the sum. So the sum of X and 30, that would be X being added rather to 30. That's what sum means. Sum means add. And then we would think 4 times the sum. So that would look like this, right? 4 times this sum. Let's move on to another example. Let's skip that for now. And let's go over to ones like number 2. The directions are, write an algebraic expression for the word expression, 11 more than E. So we think what operation is usually suggested by that idea of more, and we would say we're adding 11 to whatever E is. So we could write that as 11 plus E, but we could also write that as E plus 11. Now, ones like this are a little bit tricky because it's 9 less than the quotient of N and 5. So whenever we have 9 less, you have to have stuff first, and then you're subtracting 9 from it. So quotient, remember, means divide. So we would want to think to ourselves, N divided by 5, we could also write that as N divided by 5. That's another way to write it. Both of these are acceptable. This and this are the same thing. And then when you're taking 9 less, then you're subtracting that from what we have here. So then you're subtracting the 9. It would be incorrect to put the 9 and then the minus and then this, because then that's really 9 subtracted by N divided by 5. That's not the same thing as this, so be careful with ones like that. All right, if we look at number 4, Jake is 5 years older than his brother Kevin. Kevin is K years old. Write an expression for Jake's age. So they want you to use the variable K, and sometimes it's helpful to just come up with a hypothetical number that Kevin might be, but you have to ask yourself who's older, right? Jake is 5 years older. So that means that whatever Kevin is, we would have to add 5 to that to get the Jake older number, right? So if we're going to add, we have to add the 5 and the K together to get Jake's age. All right, number 5 says, at a restaurant, 6 people can fit at a large table and 4 people can fit at a small table. Write an algebraic expression for the number of people who can fit at L large tables and S small tables. So we're going to work in these numbers, right? Because we don't know how many tables, we just know how many people can fit at a table. And we need to take the 6 and multiply it by the L to get the large table count. And then we're going to need to take the 4 and multiply it by the S to get the small table count. But then you have to know, what are we doing with those two things, which are really terms. And then as it turns out, we would be adding those two things together. So the expression would be 6L plus 4S. All right, let's take a look at a few others. Let's see if we can find one that might be a little tricky. Actually, let's skip ahead to number 9. It says a state park charges a $6 entry fee plus $7.50 per night of camping. Write an algebraic expression for the cost in dollars of entering the park and camping for n nights. Oh, and looks like we'll have to stop there because I'm getting a phone call. So we'll have to stop there. So it's been a pleasure working with you.